Good morning, good evening, wherever you are, and welcome to episode 75 of the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And today we have a special co-host, Brian Katz, from actually episode 74. Welcome back to the show. How you doing, Brian?
I'm doing quite well, Aaron. How are you?
Good. And one of the reasons for asking Brian on the show was actually Brian knows our guest very well today. So Simon Crosby, welcome back to the show, co-founder and CTO at Bromium. Simon, how are you doing today?
Great, thanks, Aaron.
Good.
Brian.
And so, Simon, we've had you on a few times now to talk about Bromium. We did an introduction to the company in June of last year, episode 42, and we did an introduction to the vSentry product in September, episode 52. But for those that maybe missed those or are new to the show, tell us a little bit about Bromium again and about the vSentry product specifically.
Okay, thanks. So Bromium uses virtualization. So our DNA is virtualization. It's kind of the Zen crew. But we figured out a way to use virtualization to deliver security. And what we do is we do a thing called micro-virtualization, which essentially is on a per-task basis. Hardware isolates tasks running within the operating system to make them essentially, to make the desktop basically bulletproof against any form of malware or anything else. And so we use all of the power of Intel hardware isolation to basically isolate these tasks from one another and from the Windows desktop. And so we end up with an architecture which is resilient even to the most nefarious of malware, which is definitely going to compromise the operating system and do arbitrarily bad things.
Very cool. And Brian, you're actually were you a user beta tester? I know you actually have experience with the product. Tell us a little bit about your experience.
Well, we met with Simon when they were still in their stealth mode, and we took a look at the product where we're large pharmaceutical. And for us, it was very interesting because it really allowed us to really protect our people. So we've actually been spent a lot of time playing with it, hitting it hard, hitting it with viruses, hitting it with malware, and we've been pretty happy with it. Our big thing is that most of our org is on 32-bit. So, Simon, when do you have a 32-bit client coming out?
Yeah, so that requires a discussion about hypervisor architecture, which I'm happy to get into, and we should probably push that. But it's a little bit later this year, and I'll cover the specific technical reasons for that if you want to in just a moment. But Windows 7 32-bit coming shortly. We start out with Windows 7 64-bit. The problem with Windows 7 32 is that it has an address range limit of 3.2 gigs of memory. And, we kind of wanted to do more than that. That is, the average device shipping from HBO Dell today actually ships with 4 or 8 gigs of memory. And we can do much, much more cool stuff in hardware the more memory we have. So we kind of delayed it by a bit. But, Mac is also very important. As is Windows 8, particularly on tablet form factors, and even Android. That is, we're interested in Android because we can make it fundamentally secure. So it's actually turned out to be a very big project. We've also managed already to ship a beta for Windows Server, which allows us to deliver micro-virtualized RDS sessions, so Terminal Services XenApp sessions, and even inject those. So essentially safe browsing into VDI-based desktops. So it's been a huge project thus far because as we've gone into the enterprise, we found everything, including, the kitchen sink, legacy XP devices that'll never get VT. And people obviously want universal coverage. So it's non-trivial.
Very, very true. Yeah, one of the cool things that you guys recently released is you call it Lava. And I know that Aaron wants to talk about the MVC hack. And why don't you talk a little bit about Lava, because I think that leads right into Aaron's next question.
Okay, thanks. So if you go back to 2008, VMware bought a company called Determiner, and they proclaimed that that the hypervisor, courtesy of its ability to see anything in a VM, would change the future of malware detection. It turns out that they were right, but in a very different way. That is, it's incredibly difficult for a hypervisor to introspect a traditional VM and see what's going on. Here's a good example. If you see the interrupt dispatch table in the kernel getting patched suddenly with some new drivers, was that because I plugged in a USB device, or was it because my browser got attacked and the malware dropped some new drivers into the interrupt dispatch table? You don't know. Very, very difficult to actually identify in a big whole operating system VM. However, in the context of micro-virtualization, what you have is every single task is running in its own hardware-protected Intel VT VMCS. And so there's only one thing in there, and you know what it is. So, for example, one task might be an untrusted browser renderer facing Facebook. Note, this is not for the whole browser. Right? Each tab in your browser is a different untrustworthy task. Another tab might be a PDF document or a movie you're watching or whatever it happens to be. So you know what's in there. Every change made by it to the system is cached copy on write in that context. So you know exactly what it has done. And the architecture is designed such that whenever you move on, for example, close the window for the task, close the browser tab, whatever, we're just going to throw the whole thing away, that whole micro VM. And so we have an architecture which is naturally resilient to attack. Now, traditionally in the malware detection business, you have to detect early in order to protect the system. That is, there's a fundamental assumption that detection is needed to protect. And it's very difficult to detect early because of polymorphism, which makes it very difficult to understand whether it's a real attack or whether it's a false positive. And so you get lots of false positives.
Simon, could you explain what polymorphism is for those people here?
Sorry. Yeah. So polymorphic attacks are those which change every time you execute them. That is, the malware is smart enough to figure out that somebody might be figuring out a signature for it for use in traditional antivirus. And so what it does is it changes its own behavior and changes its own signature every time that it runs. And so very difficult to detect these things reliably. In our architecture, we get rid of this whole notion of detect to protect. And so malware can run its privileges and kill the kernel, do whatever it wants, but we don't care. And it's impossible for malware to escape from a micro VM. So at some point it will do something absolutely provably bad. At which point, technically the micro VM being a VM as far as the CPU is concerned, all you have to do is suspend it and go and poke around, and you have absolutely everything you need to do to provide full forensic analysis, including generating signatures for the malware based on its payload or whatever it happens to be. That process is called LAVA, Live Attack Visualization and Analysis.
And that's really kind of, if there's a theme of this entire show, it's really the idea of detection just isn't enough anymore, correct?
Yeah, but by the way, detection was never enough. So, I mean...
True. True.
Alan Turing is a brilliant English mathematician who proved this thing called the halting problem in 1936, well before the first computer was built, by the way, which basically proves that it is impossible to decide whether a program is good or bad. Okay, so we knew this all along. We just conveniently chose to forget it because in the early days of malware, it was pretty easy to detect malware. Okay, but the race has been on, and nowadays a determined attacker is actually somebody who's sitting in another country, accessing your desktop, using a remote access tool, and poking around and deliberately messing with your head. It's not just a program. And so the notion of detection is absolutely unsolvable. And so I think as an industry, we need to fully embrace that. And so let me be very bold on that one. I think it's time to demand that all of this antivirus stuff become free or just go away. Okay? And so one of the nice things about what we'll talk about our NSS testing and the penetration testing of our architecture shortly, it gives me sufficient confidence to say that the architecture is fundamentally sound, and that therefore it's high time that customers demand 100% detection ability from their vendors or 100% refund if they ever fail to detect an attack.
So that's a real bold statement there, Simon, and I think it's a perfect segue into Tal's blog post yesterday about what you guys did with the NBC attack.
Yeah, and I just wanted to kind of add, I think it really helps a lot of them. And I think when we did the vSentry podcast, where it was actually Simon and Tal and I out in San Francisco, we actually did that one face-to-face, and it was really fascinating to talk about it, but a lot of times people have to picture it too. And so I thought this was a good example of, okay, here's a website, NBC.com, who was hacked, and if you went to the site, potentially very bad things could happen. And so explain a little bit about what could happen and what the product did to kind of help everyone visualize that in their heads.
So it was funny. Yesterday morning, I'm doing the usual. I hopped in. I came into work. I did a bit of work, and then I was sitting on Twitter, as one does. And I saw a tweet from Brian Katz go by saying somebody's claiming that NBC.com has been hacked. And so first thing Tal and I did was go to NBC.com, right? So normally, anybody else would say, oh my God, NBC.com is hacked, stay away.
There's a fire, run away, not run to it.
That's right. The first thing we did, which is counterintuitive, is we go straight to NBC.com and start clicking wildly on stuff. In fact, it turned out that the attacker was cached in, and it was in a double-click ad, which was hosted on NBC.com, and it came out anyway. And immediately my desktop got hit. So just going to NBC.com, I didn't actually need to do anything. I immediately got hit. And so this thing popped in, and it immediately started to wreak havoc. Now, of course, when I go to NBC.com, that goes into micro-VM because it's not trusted by my desktop. But this was visually stunning malware. Visually stunning in the sense of what Lava does, it gives you a full graph, a directed graph of the behavior of the of the malware in the micro-VM, what it went off and did, and so on. This guy hopped into into this browser tab, immediately reached out to probably 200 different IP addresses, and random DNSs, and tried to reach out home, started listening on TCP sockets, and then started hammering the registry and overriding a whole bunch of files. At the end of it all, it had made a vast number of changes to my desktop, but I was quite happy just sitting watching it, and we were generating signatures for it on the fly. So what we were able to do is, quite literally, courtesy of visiting the site, we generate a signature, which we could then throw out to everybody and immediately protect them from that same malware. So it was kind of fun. And Lava gives us this ability to be absolutely immune to any form of drive-by attack, no matter what the thing is doing. And it also gives us the ability to provide these powerful real-time insights, which would allow you, even if you were not protected, to take the signatures that we generate, drop them into your firewall, and then protect the rest of your org.
Very cool. And so that's a good segue into the next topic I wanted to talk about, was the NSS Labs testing. And so first of all, before we go into the actual testing and the results, who is NSS Labs and why are they important?
Yeah, it's kind of funny because the desktop people don't generally know who they are. NSS Labs has been around for years, essentially as a trusted third party. In other words, the customer, the purchaser of protection suites, has trusted NSS to rank the different traditional endpoint security vendors, but they also test network security products and so on, against each other to decide who's the best in the industry. And they have a huge amount of malware that they keep, and they have this huge big test environment where they actually test and rank the different vendors' products. And traditionally, their approach has been to take each product, take a huge array of known malware, and then see they rank all the different vendors against each other based on the percentage of known malware that they managed to detect. Okay, so you get some score, 30%, 40%, whatever it happens to be, 60, 80%. None of them ever gets 100%, of course. And that's just because malware is, the battle against malware is the battle against polymorphism. So they're a trusted third party. You take your product to them, they test it, and they sell that report, or they provide that report to the industry as an unbiased third party.
And so, of course, here's the $1 million question. So, how did vSentry do?
Well, so first of all, forget about detection. What matters at the end of the day, a detection rate is not a useful number. I mean, if I have intellectual property to protect, how does that help me? If a product scores 70%, does that mean 30% of my intellectual property is going to be lost, or 30% of the time it'll be lost, or whatever, right? It's just a useless number. So the NSS guys took a look at our architecture, and they decided that they had to come up with a completely new architecture for testing. And so they went off and designed a new approach. We first engaged with them in October of last year. And they went off and they created a new test suite, which I think they call their security stack. And so the model is now entirely different. So what they do is they run all the malware of which they are aware against a product. And you start off with a golden desktop image. You then attack it, and then you see the state of the desktop after the attack. So one of the key benefits of what we do, because we naturally, courtesy of the desktop behavior, the moment you close the browser tab or you close the document or whatever it is, we just throw away the micro VM. We naturally throw away all malware. So you never have to remediate. So the golden image should always remain gold. In other words, the desktop should remain absolutely unchanged, even though a particular browser task, say my one which visited NBC.com, got completely reamed out and compromised. And so what they do is they end up doing a snapshot of the golden image before they start testing, and then doing block-wise diffs and file system-wise diffs on top of that to check that after the attack, the thing has not been changed.
So in plain English, it looked the same when it started as when it finished, and to the user, they're okay. But
they're okay. And so we scored 100%. By the way, if it had been less, I would have been mortified. That is, if there is a possibility of breaking the architecture, it would be really bad. So we scored 100%. And these were, various bits of nefarious malware that they have, but 15 of their tests are highly skilled human users using a remote access tool to deliberately try and break through the system from remote, right? So you go to like the site. So say I went to NBC.com, I get compromised, and then a remote user hops into my desktop and starts to exfiltrate files or whatever. And so they had 15 of the tests were with human pen testers, who essentially are the equivalent of advanced attackers from another country or something, trying to break through the system. And they couldn't.
And so this test is much more in depth than, hey, here's the latest scripts off the internet and a bunch of script kiddies out there just kind of trying to do attacks and things like that. This was really about as advanced as you can get in using. So
specifically, what happens is you do get compromised. That is, so my browser task, the browser tab facing NBC.com got completely hacked. What was visible there in the context of that micro VM was the cookie for NBC.com and the public internet. That is, there was no way into my corporate intranet from that micro VM, and there was none of my corporate data visible. By the way, no Bluetooth devices either, so you couldn't turn on my webcam, you couldn't save anything, and so on. And sure, this thing dropped a bunch of .exes, hammered a bunch of registry entries, and a whole bunch of other stuff, but all that gets thrown away the moment we throw away the tab. So there was no way for the bad guy to persist. Yeah.
So what's that look like to the user when they hit that site?
So that's a very interesting question. In general, the question for our customers, what do you want the user to see when they do something like that? That is, does the user necessarily need to know? Does the user need to know when they've been attacked? Or is that relevant to your SOC team? And for us, that's entirely configurable. That is, you have an ability to decide whether when a task is attacked, whether you close it or whether you tell the user or not. That's up to you. In general, it's more relevant to the SOC team than to the user.
Very cool. Very cool. Yeah, and so it really further advances what you were saying earlier of, at the end of the day, it's all about protection versus detection, and an evolution of the market and the industry. And I completely agree.
That doesn't alleviate the need for understanding who the attacker is, where they're coming from, and so on. That's all lava for us. And that's of great value to the SOC being the security operations team. The sort of stuff that we do with lava basically automates what they would naturally have to do in terms of trying to determine forensic insights. Who's the attacker? Where they're coming from? Where's the botnet? Where's the command and control center? What files are they looking for? How are they trying to get in, and so on? Where did they come from? All of that is automatically produced by the tool. And the interesting thing we've found is that deals with a real industry challenge, which is a massive shortage in security skill set. That is, retaining people who know how to actually go and reconstruct these forensically relevant details is very difficult.
Cool.
So it sounds like what you've built is not just a tool for end users. You've built a tool for security, for all these different vendors to really, be using it to say, hey, you're going to be protected, but now we can also help.
Yes, and moreover, when we set out to build the company, we had no agenda in terms of being a management tool vendor. So the product you deploy is an MSI. You manage us using System Center or whatever. Manage us using Active Directory or a security vendor's policy console. And we have no agenda there whatsoever. In fact, all the data we produce is produced as an XML formatted document. We've been collaborating with the U.S. government and an organization called MITRE, which works with the government, on an interagency declaration format, to permit rapid dissemination of information related to attacks between agencies of the government and collaborating organizations. And we output this information in that standard form, which you could throw into a security incident manager or into Splunk or whatever the heck you want, but we don't care. That is, we want the information out fast. Which is kind of funny, because if you go to your traditional AV vendors don't tell each other when they identify a new attack, because their business is selling you signatures.
True. It's the razor blade model, right?
Right.
That's very interesting. And so, how do you see this moving forward in the security industry as a whole? I know we had talked earlier about you're going to the RSA conference next week, and tell me a little bit about RSA conference and maybe some of the expectations around that conference next week.
So RSA is the industry's premier conference in security, and probably about 20,000, 22,000. So it's as big as VMworld, and everybody, it's where everybody comes, both vendors and customers alike. And so for us, it's a great opportunity to meet with customers or prospective customers. The people who we have found, it's funny, having come out of the desktop virtualization world, I'd say most desktop virtualization people don't get what we do immediately, because it sounds very security-centric. However, we use virtualization. And so we found ourselves in this interesting position. The folks who care enormously about what we do are people who are being actively targeted. So anybody who has a business that is intellectual property driven, pharma, financial services, manufacturing, legal, and so on, and who is being hammered by advanced attackers today. And in particular, if they've been recently compromised, they really get it, and they're all over it. The desktop virtualization folks, I think, are still trying to wrap their heads around what we do in terms of how it fits in with their agenda. And in general, we've found that every large enterprise, just about every large enterprise, has some form of desktop virtualization going on. They all have terminal services, by the way. And so being able to protect both virtual desktops and RDS style, so XenApp delivered applications, has also been critical. So we've added that. We now have an ability it's in beta, to run on Windows Server. And then we support multi-user RDS there. and we can do micro-virtualization for hosted applications, and then push those micro-virtualized applications back into the context of a virtual desktop or even a legacy XP desktop, which doesn't have VT.
Very, very awesome. It's interesting because I know that you and I have talked about this in the past, but the fact that so many people don't understand where you fit in, and sometimes that's a weakness for you. But you guys, especially with reading your blog post and all the tools that you have, you're really carving out a nice niche for yourself.
Yes, it looks very interesting. Look, I am confident. I'm 100% confident this is a totally awesome idea. So let's assume Bromium hits the wall and goes splat. This is one of the most powerful uses of virtualization that I've ever seen. And so there's a very interesting thing that you should start to think about. And that is that if you think about first-generation virtualization, which everybody has, certainly on server side, some people use it on desktop, first-generation virtualization is all about manageability. It's all the abilities, manageability, availability, agility, scalability, and so on. We want all of those, and we want protection. So I have a talk that I've prepared now, which is essentially called "How Virtualization Killed the Security Industry and Finally Made You Secure." That is, if you nest these two capabilities, you can absolutely deliver on that, and I'm sure we will.
Very nice. All right, well, we're kind of running out of time here. So, Brian, any other closing questions or comments before we close this out for the week?
Oh, you mentioned your Mac client. You mentioned 32-bit. I know you mentioned Android. You want to throw out any dates into the wind there? Or?
So all of them. So let's just right now we're Windows 7 64. In Q2 we swap onto our next gen hypervisor code base, which immediately gets us a whole bunch of other things. It gets us VTD support, and TXT comes within reach. So on a vPro class device, we can defend against a determined insider at the keyboard. It gets us the ability to deal with Windows 7 32-bit. It'll also bring us Mac and Android in rapid succession after that. So it's really, there's a big chunk of hypervisor development that's going on right now. So I think we'll do a Mac OS 6 beta in Q2. Windows 8 is working. Our very interesting focus on Windows 8 is both tablet form factors as well as next-gen PCs. And Windows 7 32 will probably be Q3.
Awesome. All right. Well, Simon, thank you very much for an overview of really the industry and where the industry is going today. It's really interesting, fascinating stuff. Thank you very much.
Always a pleasure. Thank you.
So, Simon, where can people go to learn more about Bromium and vSentry and all the other products?
Well, Bromium.com.
Okay.
It's straightforward. And drop me an email. I'm just Simon at Bromium or at Simon Crosby on Twitter.
Awesome. Great. Thank you very much. If you like the show, please tell a friend or leave us a review on iTunes. You can also follow us on Twitter at thecloudcast.net. You can send us feedback. Our email is show@thecloudcast.net, or you can find us on the web at thecloudcast.net, where you can find links to everything Cloudcast. Thanks for listening.